On this in a second here. Actually, we'll start putting the title. You learned about factoring before at some point. I'm going to give you two different options here, and you might like one better than the other. You might have learned to do a factor tree. A factor tree is just a way of breaking down numbers. Say a number like, what are we going to do here? 120? Let's do 120. 120, what you do, a factor tree is breaking it apart into just one by one, breaking it apart into numbers that multiply to give you that number. 120, you could start with any two numbers that multiply to 120. You could start with 2 and 60, or you could start with 10 and 12. You can start with whatever you want, okay? I'm going to start with 10 and 12. Then what you do is you look at each of those and see if you can break them down anymore. Can I break down the 10 anymore, or is it a prime number? Remember, what's a prime number again? For a number to be a prime number, it only has two factors. 2 and 3 and 7 and 11 and 13. All those are prime numbers because you can only divide them by 1 and themselves. Those are prime. Is 10 a prime number?
No.
No, because you can break it down into what? 2 and 5, right? 2 times 5. Like you're successively breaking it down into smaller and smaller multiplications. What about the 12? Can I break it down into anything? You can make it 6 and 2. Yep. Then you look at what you have left here and you say, can I break any of those down anymore? Any of these numbers, can you break down any of these numbers anymore? Which one can you break down? You can break down the 6 some more here, right? The 6 can be a 2 times 3. I'm going to highlight the ones that we have here, right? It's called a factor tree because these are supposed to be like branches, right? Kind of going down here. That's why it's a factor tree. The numbers you're left with are the ends of the branches. If you want it to be, if you can continue these down if you want, you can just keep going like this and put a multiplication in between each one, and then you look at what you got at the end. Right? Or if you don't like to keep writing that, you can just stop there and just kind of highlight them. You have that one, that one, that one, that. Those are the ends of branches. That's the. Oh, what did I write there 6 for? What was I supposed to write there? What was I supposed to write here? I made a mistake. 3, right? I think I said 3, but wrote 6. It's called a tree. I don't know why it's called a tree, because it's actually like an upside down tree. If it were the other way around, like this, a tree growing where it's splitting up, going upwards, that's a tree. I guess this is more like roots. They're kind of going down. So maybe you don't call it a factor tree. You can call it factor roots. I don't know. If you really want to. That is one option, a factor tree. The result is that you know the prime factors of 120. You can write them out. I would get used to writing them in order from smallest to biggest. You have 5 factors there. How many 2's do you have? 3. So put them all first. 2 times 2 times 2. Then what's the next biggest one? 3. And then the last one is a 5. What you're saying with your factor tree is you're saying those 5 numbers multiply out to 120. You can work with pretty big numbers this way. The other thing I'm going to show you here is not a factor tree. It gives you the same result. How about if we call it we'll give it a name in a second. We'll call it a factor something in a second. It's basically doing the same thing, but it's writing it a different way if you want to. You can just successively do some divisions. Pick one number. Instead of picking like this, you got to pick a pair of numbers that multiply. Here you can pick one number it divides by. And start small. Start with the smallest number you can think of that divides by. What's the smallest number 120 divides by? What's the smallest number you can think of it divides by?
1.
Well, okay, right. 1. But 1 is not going to help us because if I say divide that by 1, I still have 120. So we got to go slightly bigger than that. 2, right? You divide that by 2, what do you get? 60. You can just write the 60 underneath like that. Then you can pick another thing. It's like making a stack of numbers here. What can I divide it by? Can I still divide it by 2 again? Yep, so I'm going to put a 2 there. What do I get when I divide it by 2? 30. Can I divide it by 2 again? I can, right? What do I get when I divide it by 2? 15. What's the next biggest thing? Can I divide it by 2 again? No. So I got to try the next biggest prime number. What's the next prime number after 2? 3. Try 3. Can you divide it by 3? Yes, you can. What do you get at the end here? 5. Can you divide that by 3? No, right? What's the next prime number to try? Meaning you're done now, right? You can divide it by 5. What do you get when you divide it by 5? 1. When you get to 1, you're done, right? 1 and done. Those are the factors all listed at the side in a kind of a vertical stack like that. Can we call this a factor stack if you want to refer to it that way? It achieves the same thing. In the end, you know that 120 is equal to 2 times 2 times 2 times 3 times 5. But it's two different approaches. You can make a tree like that, or you can make a stack like this. I think most people seem to have learned the tree before as an approach to factoring. I think a lot of you might have more success doing it this way, because number one, they're already in order, and you always start with 2. Can I divide it by 2? Yes or no, and I divide it and I write the answer, then you just get yourself down to 1 there and you know what they are. All right? So when it talks about factor trees in there, you can make a tree or a stack. It doesn't matter to me. All right? Okay, can you get back to working on that?